Hi, welcome to the solutions video for the review and preview week 10, which is section 3.2.3 from our book in CPM. All right, so the very first one is asking us to multiply or divide the expressions below and to simplify our results. So looking at part A, we have x minus 7 over 9 times 2x minus 1 divided by x plus 5 times x minus 7 divided by 6x times x plus 5. So when you see that division sign, what that tells me first is that we want to change division into multiplication. I'm going to change the size of this here. So change division into multiplication of the reciprocal. Okay, so what that's going to look like when we do that, we'll still have x minus 7 over 9 times 2x minus 1, but then we're going to change that to be multiplication, and then we're going to flip them, so that'll become 6x times x plus 5 over x plus 5 times x plus 5. I'm sorry, x minus 7. All right, so now we're going to be able to start doing some canceling. So we can cancel the x minus 7s as well as the x plus 5s. And when we do that, we are left with 6x on the top and then in the numerator, and 9 times 2x minus 1 in the denominator. Little side note, 6 over 9 reduces to 2/3. So I can change the 6/9 to be 2/3, well, 2x over 3 times 2x minus 1. From there we can distribute. So we're left with 2x over 6x minus 3. And that is our final answer. Okay. Part B. So part B is actually a fairly complicated problem because we need to factor each of these. And if you look, A is not equal to 1, except for in the top one here. So I look and I also can't, divide each by a common factor either to make A equal to 1. So that means we're going to have to do the diamond method for each of these. Okay, there are some other methods as well, like guess and check, but in this class, we've been primarily using the diamond method. Okay, so let's split these up. Let's start with just the 6x squared minus x minus 1 first. Okay, and to do the diamond method, so we make our diamond. And we take the negative 1x in the center here, and we'll place that in this spot. Okay. Then we take our 6x squared and we times it to negative 1. So in the top box, we will have negative 6x squared. Okay. So now from here, what we're going to do is we're going to decide what multiplies to be negative 6, but adds or subtracts to be negative 1. And that is what we will put in both of these boxes. So can write that. Okay, so when we think about our factors of 6, we've got 1 and 6 and 2 and 3. So I see that negative 3 plus 2 gives me negative 1, and negative 3 times 2 is negative 1. So we are all good to go. So I'm going to put a negative 3x over here and 2x here. Okay. Once we do that, now we're able to make our box. All right, and we're going to place our original 6x squared in the first box, and our original c, the negative 1, in the bottom right box. And I'll put negative 3x in one and 2x in the other. Now we think about our factoring so we can see what would have been on the outside of the box. So we're kind of doing this backwards compared to normal when we're just multiplying. So when I look at the 6x squared and 2x, well, thinking about something I can pull from each of them would be a 2x. And 2x times what gives me 2x? Well, that would just be 1. And 2x times what gives me 6x squared? Well, that would be 3x. 3x times what would give me negative 3x, and that's a negative 1. And to check, is negative 1 times 1 negative 1? Yes. So we can write out what's on the outside of our box. So that would be 2x minus 1 and 3x plus 1. And we are done with that one. Okay. So let's look at the next one. We've got 3x squared plus 25x plus 8. We can just go to that one. Okay, so I'm going to make my diamond. Same idea, the 25x, our B goes here. And then we will take 3x squared times 8. So the top will be 24x squared. Okay. And now we need to think what multiplies to be 24 but adds or subtracts to be 25. Okay. I think it's going to be, so for these two, I'm guessing it's going to be 1 and 25 because we want it to be, so I'm sorry, this should be 1 and 24, my fault. I was looking at the 25 for C. So 1 plus 24 gives me 25, and 1 times 24 gives me 24. So I'm going to put 1x and 24x in my box here, or in that part of the diamond. So then I'll make my box. All right, so I'll put the original 3x squared here and the 8 here. I've got 1x and 24x. Okay, so we've got the 3x came from here, 3x squared. 8 came from the original, and then the 1x and 24x came from our diamond. So thinking about common factors, in the top, it looks like I can take out a 3x, and 3x times 8 would give me 24x, so I can see I'm going to put an 8 here. And then 3x times, I think that would just be a 1x, and then that would be a 1, and to check, 1 times 8 is 8, so we're good. So I'll write out 3x plus 1, and 1x plus 8. Okay, awesome. I'm going to make these just a little bit smaller so I can keep going here. Let me just minimize them. All right. So now let's take a look at x squared plus 4x minus 32. So what's really nice about x squared plus 4x minus 32 is a is already equal to 1. So we can make our double parentheses and just think what multiplies to be negative 32 but adds or subtracts to be 4. So when I think about my factors of 32, right, we've got 1 and 32, 2 and 16, and 4 and 8. So 8 minus 4 gives me 4, and 8 times negative 4 gives me negative 32. So I'm going to put a plus 8 and minus 4 here, and we are good with that step now. All right, and the very last one is 2x squared plus 7x minus 4. So this is the diamond method again. So I'm going to make my diamond. 7x goes here. 2x squared times negative 4. That'll give me negative 8x squared. And we need to think what multiplies to be negative 8 but adds or subtracts to be 7. So when I think about my factors, I think if I did 8 minus 1, that's 7, and 8 times negative 1 is negative 8. So those both work. So I'm going to put 8x and negative 1x in my diamond. And now let's make our box. Okay. So I'm going to put the original 2x squared here and negative 4 here, and I'll bring our 8x and negative 1x from the diamond. Looks like here all I could take away from both of the top would be an x. So there needs to be a 2x here and a negative 1 here. 2x times 4 gives me 8x, and 4 times negative 1 gives me negative 4. So we've got x plus 4 and 2x minus 1. Okay. I'm going to make these a little bit smaller just so they're out of my way. All right, so now what I'm going to do is I'm going to rewrite each of these to what we found them to be. So for the top line here, 6x squared minus x minus 1, we had found 2x minus 1 times 3x plus 1, so I'm going to rewrite that. Okay, and that would be over 3x plus 1 times 1x plus 8. And then that was times the other side would have been x plus 8 times x minus 4. And x plus 4 times 2x minus 1. So now let's do a little bit of canceling. So the 2x minus 1s can be canceled because these are all being multiplied together, right? I could even rewrite them so they looked more connected, but this is fine. We've got 3x plus 1s that can be canceled. And, oh, and then I also see the x plus 8. Okay. So as a final answer, all we're left with is x minus 4 over x plus 4. And whew, what a problem that was. My goodness. I promise the rest aren't as intense as that one, but that was a lot. And I mean, primarily because of all the factoring, right? So, but we did it. We got there. So let's look at part C. So we see that division sign again. So just like in the first one, we're going to have to change it to be multiplying by the reciprocal. Sorry. So this becomes so 15x to the third divided by 3y times 4y squared over 10x squared y. So now we could rewrite them so they're more together. Right, so 15 times 4, that would give us 60, and then we have x cubed y squared. And then we have 3y times 10x squared y, so that'll be 30x squared y squared. Well, 60 divided by 30 is 2. X cubed minus, or divided by x squared, we just subtract them, so that leaves me with x. And then the y squareds cancel. So our answer is 2x. All right, so part D is, there's a lot of factoring here, but these are a little bit easier, right? So I'm just going to split them up like this. So we've talked about if there's a subtraction sign and a perfect square, we know that it's just going to be x plus 3, x minus 3, right? Example, if it was x squared minus 25, there's a minus and a perfect square, that's just x plus 5, x minus 5. If it's x squared minus 16, that's x plus 4, x minus 4. That works with the perfect squares. It's kind of a nice little, trick just to be able to see it. This one, so I'm going to split them up. We think what multiplies to be negative 6 but adds or subtracts to be 5. That would be plus 6 and minus 1. For these, what multiplies to be negative 3 but adds or subtracts to be negative 2, that would be minus 3 plus 1. And what multiplies to be 12 but adds or subtracts to be 7, that would be 3 and 4. So now we can rewrite these to be x plus 3 times x minus 3 over x minus 3 times x plus 1 times x plus 6 times x minus 1 over x plus 3, x plus 4. So now let's start with some canceling. We can cancel these x plus 3s. We can cancel the x minus 3s. And I think that looks like it's it. So that leaves us with x plus 6 times x minus 1 all over x plus 1. Okay, so let's go to the next one. It says, for each rational expression below, state any values of the variables that would make the denominator 0, then complete each part. All right, so it says, use the fact that x plus 4 squared is equal to x plus 4 times x plus 4 to rewrite x plus 4 squared over x plus 4 times x minus 2. Then look for the ones and simplify. So the ones meaning like which ones cancel to be 1. So if I rewrite this, we've got x plus 4 times x plus 4 over x plus 4 times x minus 2. These cancel. So I'm left with x plus 4 over x minus 2. I'm going to rewrite that so it's over here. Okay, so looking at part B, it says use that same strategy to simplify this expression. So we have 8 times x plus 2 cubed times x minus 3 cubed all over 4 times x plus 2 squared times x minus 3 to the 5th power. So I think one of the easier ways to look at this one is kind of like we did in the last part and in a question before. Let's go ahead and change this to be 8, and then let's write them all out. So we've got 3x plus 2's and 3x minus 3's. Okay. Then we've got 4, and then 2x plus 2's and 5x minus 3. Okay, so now let's start canceling. So I can cancel here, here, and then and these two. So what I'm left with, so 8 over 4, that gives me 2 over 1. And I've got an x plus 2 on the top. Okay. And 2x minus 3 is on the bottom here. So I can rewrite that as x minus 3 squared. All right. Okay, so number 3 says Monica's younger sister is just learning how to add fractions and she's confused. She has to add 1/3 plus 2/5. Help Monica explain to her by writing a detailed step-by-step explanation of exactly what she needs to do. So let's do that first. So what we want to do is we want to make sure the denominators are the same. And then we want to add the top numbers. And then simplify if needed. Okay, so when I look at 1/3 plus 2/5, I'm going to rewrite it so it looks like this. So we've got 1/3 plus 2/5. Okay, now we need to have them have a common denominator. So when I think about what's the least common denominator that these both have in common, that would be, like for a common multiple, that would be 15, right? So if I wanted to change both of these to have a denominator that's 15, so I can add them. So 5 times 3 gets me to 15, so I need to take 2 times 3, so that would be 6, okay? 3 times 5 gets me to 15, so I take 1 times 5. So now I can take 5 over 15 plus 6 over 15, so that's 11 over 15. Okay. So then the very last question says, Janelle conducted an experiment by mistake when she left her bologna sandwich at school over winter break. When she got back, her sandwich was much larger than it was when she left it. Her science teacher explained that the sandwich had produced large quantities of rare bacterium, like some gross bologna sandwich bacteria, right? So based on a sample taken from the sandwich, Janelle determined that there were approximately 72 million bacteria present. Her science teacher explained that this is not very surprising since the number of bacteria triples, I'm gonna highlight that, triples every 24 hours. Since the sandwich had been made only 15 days ago, Janelle was sure that she could sue the meat company. The food industry standard for the most bacteria a sandwich-sized portion can have at the time of production is 100. So find out how many bacteria were present when the sandwich was made. Okay, so when I see this part that says triples here, that tells me that we are working with something that's exponential, and our multiplier is 3, okay? So because it's exponential, that means we've got our y equals a times b to the x power. However, we don't know a, which was the starting value. Okay. So what we do know, though, is it's tripling. So we have y equals a times 3 to the x power. Okay. Let's think about something else we know, too. When it comes to our days and the number of bacteria, one thing I do notice that it says is that 15 days for how long she left her sandwich, there were 72 million bacteria present. Okay. So we can plug that in for x and y so we can solve for a. So that's 72 million equals a times 3 to the 15th power. So I'm going to divide by 3 to the 15th power. Okay. So it cancels here. And if I take 72 million divided by 3 to the 15th power, that gives me just about 5.01. Okay, so what it says here is that the food production can only start with, the food industry standard for the most bacteria a sandwich-sized portion can have at the time of production is 100. So it started with 5. So if it was over 100, she could sue. But since it's under 100, she can't do that. So 100 are allowed. So Janelle doesn't have a case. All right, well, that's all for this assignment. Thanks, guys, for watching, and have a good day.